Hi, it's Jan Beta, and I'm going to do some more work on the Amiga 3000T today. In the previous episode, I determined that the Amiga 3000T is basically functional. It booted up to the kickstart screen, which means that a lot of things are working. And the rest of the restoration is actually that, a restoration. So the plan for today is to replace the electrolytic capacitors, both in the power supply, which is still in the case, and also on the main board, and then run some checks and tests and see if this machine is actually completely working. So first things first, I'm going to start with the power supply. I bought a lot of capacitors. I'm going to link capacitor lists in the video description. I also found a very detailed list of the capacitors in the Amiga 3000T power supply, which includes the sizes of the capacitors and things like that. So that's a good reference that I went by while ordering the capacitors. So the first thing we're going to have to do is to extract this from the case here. Let's see. I think getting the power supply out is just a matter of removing this top part of the casing here. And for that, we're going to have to cut this seal here, which is still intact. So the power supply was never out of this case since it came from the factory. So yeah, let's do it together. Got a really sharp knife, so we can make this a nice cut. There we go. Warranty void. So I think there's two screws that you can see here and two screws in the back, and we should be able to take this whole thing off, I guess. Okay, two screws here. These have washers on them. And then there's two screws in the back, which are painted in the case color, like most of the visible screws on this machine. Nice touch. So now this whole thing actually just lifts off. Nice. Okay. And the power supply, there are some hooks that keep it in place here. That's pretty nice, actually. So there's a connector that connects this front panel with the lock and things to the power supply. It's just a 4-pin connector. Bit dusty. This is just the umbilical with all the power going to the board. Yeah, we should be free. Okay, let's take this thing out. Whoa, it's heavy. Okay. Pretty beefy power supply. Yeah, so here is the beast. And these are the hooks that kept it in place in the casing. And there's our legend for the wire colors. We've already measured these. So 5 volts is yellow, 12 volts orange, -5 is white, -12 is red, +5 violet, that's another +5. Ground is blue, PG is green, CL is brown. So that's our clock something, 50 Hertz. It has a fan here in the back that does look surprisingly clean, actually. And it has quite a few screws around the whole casing that we have to remove to get into this. And there's another seal on here that we're going to have to break. Oh, that's actually already broken, okay. Maybe I just broke that, or it broke itself, wiggled itself loose. Maybe this was serviced at some point, but it could not have been taken out of the case without breaking the other seal. I'm not sure. Okay, this actually looks pretty clean, and it's beefy. Yeah, this is a proper power supply. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you, and they have a new service that helps you design your boards in the first place. So I highly recommend checking out the link in the video description in case you're interested in such services. Back to our A3000T. Yeah, they put a massive power supply in there, and yeah, no wonder. It has to power the board and all the expansions that are possible and all the drives that are possible in this system. So this is a lot beefier than any other Amiga power supply, I guess. I think it's a relatively old school switch mode power supply. As far as I can see, I'm not an expert on power supplies at all, but yeah, this seems pretty standard. Yeah, and we're going to have to replace all the capacitors in this. But first of all, we're going to have to remove the board from its chassis here and maybe do some cleaning. Okay, I'm going in with a vacuum cleaner with a little brush attached to it and clean the surface dust off. At first, okay, I think that's enough for an initial pass. Now we're going to have to extract this from its casing. Let's see. I think we have to remove the fan so we can get to the board at all. Going to try to remove the screws from the board. Yeah, we're going to have to remove the mains socket as well. I just noticed this massive stack of ground connections here. That's pretty hilarious. That's like 3 ground wires coming from one screw post here that's riveted into the case. And the other things here are also riveted. The threaded rod sticking out there with a nut over it. Just going to take this all out here. And of course, all the ground connections as well. This is kind of hilarious. This whole ground connector thing. But yeah, it's a proper way of grounding this to the case. I'm going to need some proper tools for this. That's a 7mm wrench. Yeah, I don't have a wrench that's small enough for these, I think. But we're going to have to make do with my pliers here. It's gonna be fine. So now we should be able to take this whole thing out here, I think. Yay! And this connector just fits through there. Okay. Oof. Can't really read the date, except it's January 25th. Yeah, there is a date code. January 25th, 1991. I don't know what that's supposed to mean. I think that's supposed to be the year. I can't really tell what it's supposed to say. Yeah. It doesn't matter. Let's do this. This is a 2-layer board. Some of the capacitors are glued in with what looks like epoxy. I'm not sure if it's going to be easy to get all of them out. The first thing I want to do is to measure the voltage across these capacitors, the large ones. I think there are discharge resistors in here. Yep, there's 0 volts on these, thankfully. So you want to discharge these larger capacitors because they can hold quite a massive charge and zap you quite significantly in case you don't do that. Or you short them out to other components accidentally and they're going to zap those components, which you also don't want. I am going to desolder the umbilical with the mains inputs here, I think, just to have that out of the way. The other cords here that go to the board are, yeah, that's a lot. I'm not going to desolder those, but I'm going to go through all the capacitors and replace them after removing this one here, I think. As I said, I ordered the capacitors that I need. Some of them I already had in my parts bin. Most of the caps on here are relatively standard values, and I'm going to link a list of them in the video description. These ones, the bigger ones, these are originally 200 volts, 680 microfarad ones, I think, two of those bigger ones. These are not so easy to obtain. I bought these off eBay. They're Rubicon and they appear to be original Rubicons. I hope so. The other ones I ordered from Reichelt.de, German trusted seller of electronics components. So I'm pretty sure these are going to be okay. First of all, let's get rid of these mains connections here, just so we have one less wire to worry about, basically. Yeah, let's mark all the capacitors that we're going to have to replace. And then I'm going to take pictures of the board as well. And yeah, I think I'm going to give it a bit more of a cleaning before I start replacing capacitors as well. Yeah, I'm going to take pictures of the board. Not sure if all the capacitors have proper polarity markings on them. So I am going to make sure that I know which polarity each one goes by taking pictures of them before I start desoldering and resoldering. And I'm not going to talk much about this. I'm mostly using Panasonic capacitors for the smaller ones and the Rubicons, which are originally Rubicons, which is pretty nice for these two larger mains filter capacitors here. This is going to be a nice little exercise, kind of meditation. But first I'm going to clean more dust here with my vacuum cleaner and then go in there with the soldering iron. Yeah, also I know there's people opposed to recapping working equipment, but yeah, these capacitors have a limited lifespan. This was working fine, as we've seen in the last video, but I want to make sure that it keeps working fine. These have a tendency to fail even if you recap them. Not very well designed power supplies, it seems. I can't really say, but yeah, I want to keep this alive for as long as possible. So I'm replacing the components that age, using mostly Panasonic FR series for the smaller capacitors and the Rubicons for the larger capacitors here. Yeah, and I'm going to go one by one, basically. So one cap at a time, so I don't get them confused, which would end in catastrophic failure, I'm pretty sure. So I don't want to risk that. I'm about halfway through this now, I think. And it's not super easy to work on this because it is a two-layer board. But I think I got everything in this corner here and the big ones. And now for the other big ones. Some of them, as you've probably seen, I used pliers to get them out and in and things like that. So a bit of improvisation here, but making good progress. Whoa, okay, wow, some of these glued down ones were really nasty to get out, as you've maybe seen. But yeah, this took a while, because they were glued in with this nasty glue. I found that isopropanol helped a bit to loosen the glue, but yeah, wasn't pretty. And I went in and removed the solder I could with some solder wick, and then I cut the leads of the original capacitors, which were bent over, and yeah, then I managed to get them out more or less. But yeah, especially the ground connections were not easy to get off. So this is definitely not a very easy experience. And I would not recommend trying this in case you've never done anything like this before. I have done things like this before, but this one is particularly nasty. Took a lot of wiggling capacitors around and trying to not damage any other components in the process. I hope I didn't damage anything. There might still be casualties here. Yeah. These are the nasty ones. They were glued to the other components, unfortunately. So now we have only a few of these left. These should be not too much to worry about in comparison. Okay, I think I'm done recapping this. Was a bit of effort, a lot more than I anticipated. This took roughly 3 hours or thereabouts. Nasty thing. especially the things that were glued in down here. These were not easy to remove. Yeah, I'm going to have to take a bit of a break, then do some final cleanup, a few drops of hot glue, because these are a bit wiggly for my taste. And yeah, these were glued in for a reason, of course. Not going to glue them quite as nastily as before. Hot glue is a lot easier to remove in case this doesn't work fully. I'm also going to check the polarity of each one of these from the pictures I took and make sure I got them all in the correct polarity, because otherwise it's going to go boom. I hope it doesn't, but you never know. So yeah, a bit of a break, something to eat, clear my mind, recharge the batteries, literally and figuratively, and then we're going to give this some final touches. I double checked the polarity of all the capacitors with my pictures that I took before, removing the original capacitors, and I think I got everything in the correct orientation. I hope so. There's also markers on the board, and I double checked with those as well. I'm going to do some more cleaning and some hot gluing of the larger capacitors, basically just putting glue where there was glue originally that I ripped out with the old capacitors. Yeah, especially the fan needs a bit of cleaning. You can, of course, replace this fan with a better one. I have a Noctua fan with the correct size. That's an 80mm fan, but this is a PWM controlled fan, so it's not ideal. The original one is just 2 wires, 12 volts, running at a constant speed all the time, basically. So PWM is not the way to go for this. Maybe I'm going to go in again and replace the fan with a proper Noctua, but for now, I'm just going to use the old fan and clean it up. So yeah, some cleaning, some hot gluing, and then we're going to put it back in its casing and try it out. I also noticed that there's a zip tie here, just stuck between the fins on this heatsink, that snapped. Holding this part here, the upright board, together with the rest. So I'm just going to replicate that with another zip tie, I think. That should probably do. Oh, we need to reattach the mains power, of course. Yep, looking good. Back in the casing it goes. Let's see. So, okay, it's time to test the power supply. Not going to connect it to the main board, of course, at this point. I'm just going to see if the voltages are somewhat correct. I just loosely put the lid on here. I extracted the little power switch section from the case, from the main case, and I'm going to hook this up to some mains power now and measure some voltages. Of course, these are going to be off a bit because there's no load on this, and it's actually not recommended to run these without a load, but this one did fine when we initially tested it, so I'm pretty confident that it's going to somewhat work if I did everything correctly. So yeah, let's see. I'm just going to plug it in now. No explosion so far. Let's see if it powers up. It doesn't. Okay. That's not good. No fan spin. I think I broke the power supply. Or is it just the fan that isn't working? Ah, this sucks so much. We don't get any voltage on the power connector here. Oh. Yeah, I'm going to need to double check everything, I guess. That sucks. So it kind of wants to work. The fan is kind of spinning up, but not really. And then it goes into shutdown, basically. Okay, connected a hard disk. Let's see if it does anything. Nope. But it wants to start up. Okay, yeah, that sucks. It does want to power on. The fan is kind of spinning a little bit. But then it just shuts down. So something is fundamentally wrong here. I think I have some troubleshooting to do, which is of course not fun. Not sure what that is. Probably a bad solder joint, so I'm going to have to take this all apart again and do some troubleshooting. Oh, that sets this project back quite a bit. Oh, this sucks so much. I'm a bit devastated. I tried to do everything I can, but it wasn't enough. I'm not sure what's wrong with this, and as I said, I'm not an expert at all on these switching power supplies. So, yeah, this sucks big time. I am going to take it apart and have a look and troubleshoot it, but probably not in this episode. This is going to be another episode somewhere down the line, probably. Yeah, I had a working A3000T. Now I have a non-working A3000T. I'm pretty sure it can't be anything super major, but yeah, it's going to take a clear mind, and I am a bit too exhausted to take it apart again and measure everything. So the next episode is probably going to be power supply troubleshooting, and if that doesn't work out, it's going to be replacing the power supply with a modern PC power supply, which is another option that is actually pretty good, I guess, because these power supplies are from the 90s and they are not the best quality, as you've probably seen. Yeah, thought this would be an easy thing to do, and I planned on recapping the board, but I'm not going to be able to do that with a non-working power supply because I can't really test things. Yeah, sorry that this was such a letdown. I am pretty devastated. And I know the comments are going to be hilarious on this. So I'm going to do the best I can to troubleshoot this and probably maybe fix it at some point. For now, that's it for this episode. Thank you so much for your time. Hope you are not as disappointed as I am at this point. There are ways around this, and I am going to figure it out eventually. I hoped this would be the final stretch of this journey. But yeah, extra special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are on my website and in the video description in case you want to give me some support. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye. It looks nice though.